Hey guys, welcome for our notes. Not live, but still useful. So we're going to start with this data right here. So this data right here, in chapter 7, which we talked about before, is about scatter plots. Okay, so scatter plots are when you have data, right, that has two variables. Um, So we'll have, instead of just having the one variable like we had in chapter 4 and chapter 5 and all that stuff, we're going to have what we call bivariate variables, which means you have two variables, our x and y. The x variable we typically call the explanatory variable because we're using it to sort of explain the other one. So it's called the explanatory variable. And the y variable is usually called the response variable because somehow the y variable is responding to the x variable. So that's called bivariate data. Okay, so we'll have an x and a y. So that means every point, every data point that we have, like this one was some neighborhoods with a percent of students in that neighborhood that get free and reduced lunch. So this is like percentages of poor people in a neighborhood. That's a way to measure that. And then percentages of children that wear their bike helmets in the neighborhood. So somehow this data was gathered. And so for this one neighborhood, we have an X and a Y. Okay. So that means that we have a coordinate, right? We have, they're going to use the reduced fee lunch as their X coordinate and the bicycle helmet wearing as their Y coordinate. So we have a point, 50, 22.1. Well, we're going to take all these points and we're going to throw them on a graph. So our graph that we typically do, right, in advanced algebra, which you did, um, is a scatter plot, okay, where you put the explanatory variable on the x-axis and you put the response variable on the y-axis. Okay, all stuff that I think you already know. Okay, we need to make up a scale. So when you're doing your, just like we did on box plots and that stuff, we have to make up some kind of scale. We don't just want to put dots on there without making up a scale. So you want to make sure you're labeling your axes. You want to make sure you have a scale. So some things that are important for FRQ questions are label the axes, and make sure you put a scale on both. These are just little things. Now, when you use a computer program to make your graph, you know, chances are it makes all that for you. If you use Google Sheets, that can make scatter plots. Microsoft Excel is what I use sometimes on the computer to make scatter plots. We're going to use our calculator a lot to make scatter plots, so we'll learn how to do that. So first thing I want you to do is let's make our first scatter plot. So let's go ahead and take this data right here and let's throw it into the calculator. So I'm going to pull up the calculator. I'm going to move it over here. No, we don't want you big. No, no, we didn't want you that like that. Okay, so we're moving it over here so you can still see the points. We're going to go same place we've always gone, stat, edit, but now we have to put in the points. So the points go in, one column will be the X's, one column will be the Y's. You got to make sure the right ones go together so they're the right point. So I'm just going to put them in order from what they have them in the list. I'm going down the list here, putting in all my X variables, making sure I don't mess up here. 73, 51, 51, 11, 2, 19. Hey, gotta yell at my dog. Stop. The beast over there. Okay, and then the y variables, 22.1, 35.9. It's funny that these are all decimals, but the other ones were not. 57.9 and 22.2 and 42.4 and 5.8. Wow, not many people wear a helmet there. 3.6, not many people wear a helmet there. 21.4, 55.2, 33.3, 32.4, and 38.4. And we should be matched up. Okay, so if these two amounts don't match, you're going to get an error message when we go to make our scatter plot. The x and the y should have the same number of items because each of them is a data point. So there shouldn't be different numbers. If there is, you probably mistyped somewhere or you forgot a number. You probably didn't forget a number because they're in your list and they're easy to see. So you probably mistyped something. So we have our data in x and y. So remember what column you have which one in. And then you're going to go to your stat plots. So second y equal, just like we always do. It's still on from our last chapter with our histograms. We're going to change it to the first one. So the scatter plot is the first one with no connectors. You pick that one and then you tell it my x's are in L1, my y's are in L2. If they're in somewhere else, you go ahead and you hit second 3 right, and there's L3. Okay, so you can just tell it where your data is. What kind of dots do you want? I'm just going to keep it with those dots. And then that's it. And then zoom. Don't forget, you always have to zoom stat. And then boom, you should have a nice scatter plot to look at. Okay. Now, it doesn't tell you the numbers here on the axes. You could use the trace button, and you can use the trace button to move around to the different points and see which ones are which. But you still can't really tell what the axes are. If you go to the window, you can see that they went by 8 on the x-axis, and on the y, it looks like they went by 1. Why would they go by 1? No wonder we had so many lines on the y-axis. You guys, seriously? Seriously, computer? Go by 10. Come on, okay? There were way too many lines on the y-axis. So there we go. Scatter plot. Boom. You made it. Okay. So we're going to be making scatter plots. I didn't give you a lot of homework problems where you had to make it. I think I gave you one or two where you actually had to make it and I gave you the data. Okay. That's real life. Real life is someone didn't make it for you. You're probably going to have to make it yourself and you're going to have to look at it. Okay. So what are we going to do in chapter 7? Well, after we learn how to make them, okay, we're going to have to interpret them. Okay, so we're going to have to explain what we see and we're going to have to describe it. So that's where we're going to start with how do we describe a scatter plot, right? How do I describe this scatter plot? Okay, so there are 4 things you need to describe on a scatter plot. Okay, let me go to another page. Here are the 4 things you need to describe. Describing scatter plots. So the 4 things you need to describe on a scatter plot. First thing you need to describe is the form, we call it. Okay, so form, people are like, what the heck is form? Form is what sort of shape does it make? Is it a linear pattern? Is it a curved pattern? Right? Those are the 2 main patterns we're looking for in scatter plots. Is it linear or is it curved? In general, we know they're not going to all follow the same line. Like that's probably impossible to have data that perfect. But in general, do these points look like they're following a linear pattern with their I sort of call it a cloud here. There's like a cloud of points. Does that cloud look linear or does that cloud look curved, right? Linear, it looks sort of linear, right? So I thought that cloud looked sort of linear on that one. Okay, if I go back here and sort of sketch out what we saw, okay, we saw something like this, okay? So I think that pattern doesn't look like it's curving. I think that pattern looks like it is in general a nice linear pattern, okay? So linear or curved, that's basically what you're looking for. Does it look like it goes in a straight line or does it look like the data sort of goes like that, okay? Um, that's what we're looking for. So we're trying to find out if we have one of those two kinds. Um, so that's the form. Always needs to be addressed. What form does your graph have when you look at the points? Second thing you need to look at the points is after you refer to the form, you probably talk about the direction. So the direction is either positive or negative. That's it. Okay, positive or negative. Okay, positive means as the explanatory variable increases, the response variable also increases. Also increases. Positive pattern looks like that. Okay, right? As the x variable increases, the y variable increases. A positive pattern. Sort of like slope. So if you think back to algebra and slope, positive slope means it's a positive direction. Now, when they ask you to explain what positive means on a graph, they don't want you to say, it means it goes up. That's too elementary of an explanation. What they mean is they want you to describe it sort of like I've described it here. As this increases, the blank increases with it. That's like you describing the direction. Negative direction is the exact opposite. As the explanatory variable goes up, so I see explanatory variable increases, the response variable decreases. That would be a negative pattern going down like that. Okay, so as the x increased, the y actually decreased. So direction, important. Okay, we talk about what kind of form do we have, then what kind of direction do we have. So let's go back to our graph right there. What form does that have? Right? Looks like a linear. I don't see much of a curve. Now, if these points had been down here farther, then maybe I would have said curved, but these look pretty linear. I don't care that these are down here hanging out. And then what direction are these going? Well, as the increase in poverty, basically, because that's a measure of poverty, as the neighborhood increased in poverty, the bicycle helmet wearing decreased. So, right, these neighborhoods were very poor neighborhoods, and the bicycle helmet is very small use in those neighborhoods. Um, this neighborhood's very affluent and not that poor. Bicycle helmet use is much higher. So the general pattern here is a negative pattern. As poverty increases, bicycle helmet use decreases. You see how I described that? That sort of way that I just described that in words, that's what they want you to do on problems. describe it in context. Don't say, as the x variable increases, the y variable decreases. That has no context of the problem, right? We're doing real problems, you guys, with real data, with real things. So you should use what they are. As poverty increased, bicycle helmet use decreased. That's perfect, okay? So don't be afraid to use the problem, whatever it is about. Okay, so we got the form, we got direction. Those are two big pieces, two huge pieces. Okay, so the third piece is just something new we're going to learn about. Um, it's called strength. So strength refers to how closely do the points follow the pattern. That is a reference to strength. How closely do the points follow a pattern? Okay. Are they all really close to that pattern or are they pretty spread out? Okay. So a strong correlation, the points are all really close. Strong means the points are all very close to the pattern. Not to each other, they don't have to be close to each other. They just have to follow the pattern. That's what strong means. Weak means they're really far, right? Weak means the points are not very close to the pattern. And when I say pattern, I mean like the overall pattern, okay? If you're really close to that overall pattern, that would be strong. If you're really, all the points are really spread out, that would be weak, okay? And we'll practice on that, and I'll give you some examples so you can see what strong and weak look like. Um, so we are going to refer to how strong it is. So when I'm looking at that graph that we made, this is pretty strong, okay? Just my experience, you don't know yet. This is pretty strong. These points are not actually over here, right? Really strong over here. The 1, 2, 3, 4, 5, 6, 7, 8. These 8 points here are like following a very, very distinct pattern. These 4 points in these neighborhoods, they're a little bit off. So I would say overall, this is probably a moderate strong. It's not as strong. If you take away these 4, then I would have said it was really strong. But with these 4 in, I'm going to say it's probably moderate strength, but it's definitely not weak. There definitely is a pattern going on here. Now, if we had taken away these 4 points, imagine they're not there. Now we don't have as strong of a pattern. Because imagine zooming in on these points right up here in this part, and you don't have a very strong pattern. They're pretty spread out if these points weren't around. So these points actually have a lot of power in this data because these points are really driving this pattern. Without these 4 points here, this pattern is probably not as strong. So interesting. We're going to be analyzing scatter plots like that. You're looking for points like that, points that have a lot of influence. Those are called influential points. We'll learn about them in the next chapter. So we got form, we got direction, we got strength. Okay, there's only one more thing. Okay, and you know what it is because it was really similar on the last chapter when we did our describing of just quantitative data. The last thing is unusual points. I probably didn't spell that right. I never spell that right. Unusual points. So unusual points are there any points that just don't fit the pattern? Are there any points that don't fit the pattern? Those would be unusual. So if you see something that doesn't fit, then you should point it out. You should circle it. You should tell me what the point is. Okay? We're looking for unusual points. Okay? So that is the last piece of your describing. So a lot of your homework problems you're going to have are on describing. Okay? So this is sort of the process. I need you to go through this process. What's the form? What direction is it going? How strong is the relationship? And is there anything unusual going on? You may not always have number 4 because there may not be any unusual points. Um, these things, when you describe all of them, get in the habit of using context. Okay, I'm going to be honest with you. AP exam FRQs that are on Scatterplots, they do a lot of simple questions about just asking you, what does positive mean? What does strong mean? They do a lot of that. So you guys being able to answer simple questions about what positive means, what negative means, what strong and weak mean, that is going to be very valuable. Okay, that's an understanding. Like that has no mathematics involved. It's just you understanding how to explain it to somebody and what everything means. So really important on homework that you write all that stuff and you practice writing that stuff and you put it in context of the problem. I don't want to have to reteach you in May and retrain you to do that. I want you to already be trained to do that. So there you go. So there's your scatter plots. So let's do a problem. I think I have one here. I do. Lucky me. Who knew? Okay. Hurricanes develop low pressure at their centers. Okay. So we'll do this example. This pulls in moist air, pumps up their rotation, and generates high winds. Okay. Standard sea level pressure is around 1013 millibars, or 29.9 inches of mercury. Hurricane Katrina had a central pressure of 920 millibars and a sustained winds of 110 knots. Here is a scatter plot of maximum wind speed versus central pressure for 163 hurricanes that have hit the United States since 1851. So there you go. It's a lot of data right there. The pressure of the hurricane is on the x-axis, and then how fast the wind speed was is on the y-axis. Okay? So first thing you got to do is you got to understand it. You got to understand the graph. You got to understand the variables in order to do all the description. So their question is always going to be describe, and we're going to go through and we're going to describe it. So some key things I might point out. Form. What pattern do you think it takes? Looks like a linear pattern. Okay. So a linear pattern where that goes in a negative direction, right? And then I usually like to put context. So I'm going to explain what that meant. That means as central pressure increases, in the hurricane, the wind speed decreases. Huh, negative pattern. As the pressure increases, the wind speed decreases. Okay, you just put context in right there. That's amazing. So just adding that sentence, like interpreting what the negative means, will probably get you your full credit on context. And then strength, I would say the pattern has moderate strength, right? They do follow I mean, if I'm thinking back to, we're going to do in chapter 8, but you're thinking line of best fit, it does follow a pretty good pattern here, right? There's sort of the pattern I'm thinking. It does follow that pretty well. So that's why I said moderate strength. The points weren't super far from that overall general pattern. So that's why I said it was a moderate strength on there. Okay. And then anything unusual? You know what, you guys? Maybe this one is a little bit unusual. Um, so I might point that one out and say there was a hurricane that had a really low central pressure, but it did not have high winds. And I'd be wanting to know like why. There was one hurricane with really low pressure at, I don't know, let's come up with a number, 945 millibars, and only had maybe 70-mile-an-hour winds. 70, not mile an hour, 70 knots in wind speed. So to me, right, I gave you the location of where that point was by telling you the coordinate. I have context in there. It was unusual, right? There's also this one too I could point out. So I really could point out both of these. They were very, very unusual. I don't see any unusual ones here. They pretty much follow the pattern. Those were probably the two most unusual points there. Um, but that's what we do. We're going to learn more on that. So the unusual stuff is not set in stone right now. We're going to keep learning on unusual. Chapter 8, Chapter 9, we're going to learn a little bit more about unusual points and what we look for and some special vocab. So right now, we're just noticing them, pointing out where they're at. Okay? You don't know all that stuff yet. So that's what we're doing on this stuff. Describing what you see, go through all of that. That's a typical problem right there. And that's actually a really typical AP exam problem too for linear regression stuff. Okay, so the only other thing, I thought I was going to write stuff there. I guess I'm not. I wanted to go over this thing called correlation. Okay, correlation. Correlation is the description, the numerical, okay, numerical description of strength that tells us how well the points follow the pattern. That is what we call correlation. How well the point, oh, sorry, I forgot, there's a key word here, I forgot, the linear pattern. This is the key. If I left that out, I would be punished. Okay? Correlation is always telling us the strength or a linear pattern. People use the word all the time, and the data might not be linear, and they'll still say correlation because people misuse it. It's really common for people to say, those are correlated. Are they linear? And they might not be linear, but they don't know any better. So they use the word correlation. What they should use is, if you don't know if it's linear or curved, use the word association. Association. No, that's not. I didn't spell that right. So, yeah, I did. Association. Yeah, use the word association. Association can be curved or linear, right? Just says it follows a pattern. So if I tell you something has an association, it could be curved or linear. But if I'm talking about the word correlation, then it should be talking about a linear pattern. That is something that people mess up. Let me move this so you can see a little better. So there's this thing called Pearson's correlation coefficient, right? Mathematicians have made a way for us to measure strength. The way it's calculated, it's a lowercase r, always a lowercase r, and it's calculated by doing this crazy formula where you do zx, z-score of all the x's, times the z-score of the y variable, and you add those all up after they multiply them and divide them by n minus 1. That is how we do correlation. You guys, we are not going to do it by hand, okay? Again, remember, we are the interpreters. We are not going to sit here and do something that I can program a computer to do. So take the z-score of all your x variables and the z-score of all your y variables. So you would have to change your data from x and y into z-scores of x and z-scores of y. So you would need to know what's the mean of all the x's, what's the mean of all the y's, what's the standard deviation of all the x's, what's the standard deviation of all the y's. So you would need all this other stuff to calculate these z-scores. Right, a computer program could do that for you. You put in all the numbers, it could figure out z-scores for you if you wanted. You multiply the two z-scores of that data point, and then you add them up, and you divide by n minus 1. So you would take, like, if we converted, go back to our data. If we converted these to z-scores and all of these to the y-scores, and then we'd have to multiply that z-score times that that z-score. We'd multiply the two z-scores for these, get a number. We would do that for every single point. And then we get all those, and we would add them all up, and then we would divide by n minus 1. It's terrible, right? You don't want to do that. It's like standard deviation. We did it one time to understand it, but I don't even make you do correlation one time because that's how you're not going to do it. Okay, you're going to use your calculator. Your calculator will give it to you. Okay, so it's not anything big deal. Now, what are the numbers? What's going to come out of this formula? Here's all that can happen on this formula. You can get a number between -1 and 1. That is it. There's no correlation bigger than 1. There's no correlation less than -1. This is it. These are the only correlation numbers you can have. Okay, this is what that formula is going to give us. So if someone tells you the correlation is 1.3, you tell them they must be mistaken because there cannot exist a correlation of 1.3. Cannot exist. So here's what we do know. Okay, correlation tells us a lot. It tells us about strength. It also tells us about direction. So the middle, if you get 0 for correlation, you work all this out and you get 0, that meant there was basically no pattern. Okay, there was no association, there was no correlation. A low number like 0 means not good. Those points were all over the place. Okay. A really high number like 1 is perfection. 1 means that every point that you had on your scatter plot is on the line of best fit. Every point there is on the line of best fit. If that happens, which doesn't happen very often, but if it did, that would be a correlation of 1. Okay, this one I drew was a negative pattern, so guess what? That one would have been a correlation of -1. So your negative pattern or your negative correlation numbers, when you have a positive pattern in your graph and you're going up, it's positive. So the positive and negative, all it tells you is which direction. So if you tell me the correlation is 0.8, I know it's positive. So I don't even have to see the scatter plot. I know it was a positive general direction. Okay, if you tell me the correlation is -0.8, I know it was a negative pattern, okay, on the direction. So the negative and positive is sort of nice because it gives you a way to know without seeing the scatter plot. And then the size of the number tells you how closely the points go around the pattern. So strong we consider like 0.8 to 1. Any number between 0.8 and 1 or -0.8 to -1, those are strong patterns. The points are really close. 1 is perfection. You'll probably never have 1. Moderate strength, between 0.5 and 0.8, right? Moderate strength, negative 0.5 to negative 0.8. That's pretty strong, okay? Weak relationship is probably less than 0.5. So you get like an R value of 0.4, 0.3. Those are weak relationships. So those points are really spread out around the pattern. Okay, they're pretty weak. And in order to get a zero, okay, there's not a lot of ways to get zero. Zero doesn't happen very often. In order to get zero, those points have to be like perfectly balanced um, to give a horizontal line of like there's no pattern at all. Like it's a horizontal line would give you a zero. It's sort of like slope. So it's really doesn't happen very often. Okay, that would be zero. So that's a big deal. Okay, that is something new. Probably haven't done that in advanced algebra. I think I taught it in my advanced algebra because I taught stats, so I wanted them to know what R was. Um, and we went over a little bit. But that's a big part of this chapter too, is knowing what R means. Means correlation. What does it describe? What do the numbers mean? Because you're going to be the interpreter of that number. Someone else is going to give you an R value. You're going to be the one that has to tell them what that means. They're going to tell you, I got an R of 0.75. And you're going to have to tell them, oh, that means your pattern is positive direction and it's pretty strong. It's moderate strength, so the points are probably a little bit spread out, but not bad, not bad. Okay, so it takes some practice. Um, like I have some things where we practice and I spread out some points and I say to you, okay, what correlation would that be? And people look at it and they try to guess. Um, This one, I'm gonna be honest with you. This one's pretty spread out. Not much of a pattern going on here. This one's gonna be really weak. I think this one probably be close to like 0.3, 0.2. Um, so I would think that's sort of what that correlation would be. If I give you one that looks like this, that's probably a nice correlation of negative. It's negative because it's going down, but it's probably close to zero point 0.8, 0.7, somewhere in that area. So the one we had on our graph, right? There was some spread here, but there wasn't a lot of spread here. This actually would have a pretty good correlation. Okay, my guess is going to be about negative zero point 0.8, negative zero point 0.7 for this one. I might be wrong, and we'll learn how to calculate, but I don't want to show you now because I don't want to get you all confused showing you where how to calculate on your calculator. Okay, because we're not in charge of that. We're in charge of just guessing right now what the correlation is. Okay, so that's our way to measure strength. So when you describe strength, I didn't write it on there, but when you're back there describing strength on your description, this is a good place to put in correlation. Okay, so you could put in correlation. If it had a linear pattern, put in correlation if it's linear. So that's what I would do. Okay. Um, if it's not linear, don't bring up correlation. You can say it has a strong pattern, but you don't have to say correlation. You can say it has a strong association. Um, so there's correlation. Okay, we went over that. Trying to think. So here's one of the big messages out of this chapter. This is a big message on scatterplots. Scatterplots, people think that the x variable causes the y variable. That's what people think. Okay. Oh, I'm comparing these two things. This is the explanatory. That one responded to that one. Perfect. This one explains this one. Why? Not always true. Okay. Let's look at our data right here. Okay. I just gave you the graph of basically the percent poverty in a neighborhood and the percentage of kids that wear bicycle helmets. And what we found out is that the poorer the neighborhood, the less the kids wore bicycle helmets. Okay, that's what we found out. Does that mean that poverty caused them to wear less bicycle helmets? Or could it mean something else out there might be have some effect on why they're wearing bicycle helmets or not. That is the moral of the story. Just because this is the X variable and there's a relationship between these two variables does not mean that this X variable caused the Y variable. It doesn't mean that the percent poverty in a neighborhood causes the percentage of bicycle helmet wearing. There might be some kind of relationship going on, but it doesn't mean the X causes the Y. So we have a saying for this. It's a really, really important saying in AP Stats. Correlation does not mean causation. Really important to know. This is common in our world that people misinterpret and imply to other people that don't know any better that correlation does mean causation. There's a lot of people. You're going to read articles in the newspaper. You're going to see um, stuff, data put out there. And there's a lot of people that imply that the X variable causes the Y variable. We don't know that. Okay. Um, we don't know without running an experiment. Without running a randomized experiment. Okay, you can't just say because there's a relationship between the two that the X1 causes the Y1. In order to do that, in science, we run experiments. We control a variable, we change it, like some of these people get a placebo, some of these people get a vaccine. And then we compare the results afterwards, right? We have controlled one of the variables, and then we try to see if there's something that happens. That's how we establish causation. We run an experiment to establish causation. I did not run an experiment, okay, on the bicycle helmets and the poverty. I didn't I didn't pick a random group and say you have to be poor. I'm going to make you poor and then we're going to see if you wear bicycle helmets. We didn't do that. We didn't randomly assign people that have to be poor and some don't. We can't do that. That's impossible. Okay? So this is an impossible experiment. So there's no way for me to figure out if this causes this. There's a relationship going on, but there's probably a relationship because of some other variables that affect both of these. So those are called confounding variables. We don't know. We don't know. But the moral of the story is correlation does not mean causation. Okay? Some other things about correlation. Correlation should only be reported for linear patterns. Okay? Correlation should only be referred to on linear patterns. Okay, it should not be on curve patterns. You should not talk about correlation. Okay, so if I give you a graph, this is a good example here. If I give you a scatter plot and it looks like this, here's your scatter plot. Boom, 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 boom. There's your scatter plot. My question would be to you, what's the correlation probably going to be? Well, the correlation on this is probably going to be close to 0 because some of the points are above. If there's a line, where would the line be? The line of best fit? Well, on this graph, I don't know. The line of best fit might be right about that. Okay, so if there's a line there, these points are pretty balanced over and above the line. So, so that just because it follows that doesn't mean it has a correlation. It doesn't really have a correlation there. It's not linear. But these points do follow a curve pattern, and that curve pattern is pretty well defined. Okay, if you're looking at this and you're thinking back to your advanced algebra days, you'd say, wow, that looks a lot like a parabola. And it does. And you're right, it does follow more of a parabola pattern. So this has a strong association. It definitely follows a strong pattern. That pattern is curved. Um, so just because it's curved doesn't mean it's weak. It can be strong and following a curve. So that's a strong association for a curve. It's not a strong correlation. It is very weak, almost no correlation. So correlation refers to linear patterns. You can refer to association and strong on curve patterns. So that's something that people mess up a little bit. Okay, I want to show you an applet that helps you with correlation a little bit. I should put the link. You know what I should do is I should put this link on Google Classroom. So you can do it too. So I can play with points on here. Let me make this so it's not too big. I can play with points on here and it will tell me the correlation. Um, I think it will. There, correlation coefficient, 1, because there's a line that goes right between those 2 points. Correlation of 1. Let's add one there. Oh, 0.891. Let's add a few. There's your pattern. 0.7669. Positive, right? The overall pattern is positive. The points have some variation around that line of best fit. So you can start to play with it. If I make them wider, you should see it start to go down, right? Ooh, we're almost 0. Oh, we're really close to 0. So now we have almost no pattern. Because seriously, look at that. Where's your line of best fit? I don't know. I'm looking at it and I don't know where it is because there is none. Okay, it's not very strong. So I'll put this on the applet. You can play with it and sort of see. Like, what if there's a lot up here and then there's this one hanging way down here? It's really strong because of this one. Now watch what happens if I take this one out. Can I take this one out? Oh my gosh. There's a negative pattern here if you zoom in, but if you put that down there, it becomes positive just from this one point. So that's what we're going to focus on in future chapters. This point is a big deal. This point did a lot to this thing. It changed the whole pattern from negative to positive. Made it look like it was weak because it was only negative 0.3, so a pretty weak negative pattern to a really strong positive pattern just because of one point. So those 1 points, you guys, like that, they can be a pretty big deal. But I'll put a link to this on our website and you can play with it. But it's fun to play with and see what correlation does without you actually calculating it. So that is it, you guys. That is our notes for chapter 7. Homework I will put on Google Classroom. You can work through it, try to graph, do a lot of describing, use context. You should be good. Okay? Have a good weekend.